Okay, shall we start?
Let us check the
Maybe
timing.
1 minute.
The stage is yours. I just deactivate my webcam. Let us know if you need us for anything in the background. Thanks.
Okay, thank you very much. Hello, everybody. Good morning and welcome to the panel of Psycholinguistics in the second day of the International Conference on Science of Language and Brain. My name is Ramin Golshai. I would like to start the session with a short introduction on the topic. As a subfield of cognitive linguistics, as a subfield of cognitive science, psycholinguistics is an interdisciplinary field that studies psychological processes underlying language production, comprehension, and acquisition. Contemporary psycholinguistics began in 1950s, although its roots can be traced back to 19th and early 20th century. Today, psycholinguistics is a dynamic and fast-growing discipline equipped with advanced technologies to shed light on the mysteries of human mind. Aside from informing theories of language production, comprehension, and acquisition, psycholinguistics has practical applications in areas such as reading, bilingualism, and language disorders. In today's panel, we will have presentations on different domains of psycholinguistics, such as language comprehension, syntactic processing, phonetics, and applications of eye tracking in cognitive linguistic research. Before beginning today's presentations, I'd like to remind that for efficient time management, I will interrupt 5 minutes before the speaker's time is over in oral presentations and 1 minute before in poster presentations. Now, we lose no time in getting to our keynote presentation delivered by Professor Dr. Pia Knoeferle. Dr. Pia Knoeferle received her PhD in psycholinguistics in 2005 from Saarland University in Germany, with a dissertation on the role of visual scenes in spoken language comprehension. Since 2015, she has been professor of psycholinguistics at the Department of German Studies and Linguistics at Humboldt University of Berlin, and is currently also affiliated with the Einstein Center for Neurosciences and the Berlin School of Mind and Brain. Professor Knoeferle's publications include over 100 articles, book chapters, edited volumes, and papers in conference proceedings. At Humboldt University, she has served as head of department and is currently vice dean for research at the Faculty of Language, Literature, and Humanities. She is also a member of the ethics committee of the German Linguistic Society and an associate editor for several journals, including Acta Psychologica, Cognitive Science, and Frontiers in Language Sciences. Her current research focuses on real-time visual and linguistic context effects in language comprehension using eye tracking and ERP methods. I'm very pleased to invite Professor Knoeferle to deliver her keynote presentation entitled Context Effects in Language Comprehension.
Thank you much for the kind introduction and for having me at this conference. It's a pleasure to be here virtually on this platform. Can you hear me okay? Yeah, just to double check.
Yeah, great.
Good, thank you. Right, so context effects in language processing. What do we mean by context? We look at a variety of contexts, specifically mostly in comprehension. One example for a potential type of context could be a photo like this one here of a shack in the middle of nowhere. people might see this image and then read a sentence that more or less relates to this image, like the farmer of Withering lives in a rickety tin shack. That's a fairly good match. There's no farmer, but it's a description of the shack that you see. So process might be relatively easy here. By contrast, if you see an alternative image like the one on the right, showing a castle, and you then read farmer of Withering lives in a rickety tin shack, this doesn't match, right? So you're struggling to integrate the context here in the form of a picture with the ensuing language. So probably processing difficulty would ensue. And an interesting question is, when during sentence processing would that happen? Is it early on, or at the verb, or once you get to the noun that really is mismatter? One case, but not in the other. You can also flip this. You can present one image and then another sentence. So the tin check and then the Count of Withering resides in a splendid manner, or the castle and then the Count of Withering resides in a splendid manner. Again, we could ask here, with what time course is context integrated in language comprehension here? As people read a sentence, and the blue rectangle here is a very coarse-grained implementation of where people might look as they read the sentence. We can eye track this and also record their brain potentials during that process. And then we can look at, would context be already integrated at the verb, for instance, because resides don't really match a sort of tiny shack, maybe, in most contexts, or wouldn't later in the sentence at splendid man. So those kinds of contexts we look at. Here you would have a reversed match for the castle, but not for the shack. And of course, this could be sort of graded, right? It's not a yes-no issue. All right, so today we'll be talking about context effects in language comprehension, language processing, with a focus on how do you accommodate context effects and what sort of variability do you need to take into account. We'll have a brief look at language representation, mostly focusing on reference, but also beyond that. Then an example from research using event-related brain potentials, integrating verbs with actions in context, but then also following an initial introduction of one account of how you could accommodate real-time context effects during language processing. We're sort of going to look at extending the account, the coordinated interplay account, and looking at beyond reference, and also beyond the participant group that we very often use because they're just easily available, right? 18 to 31-year-old students that are around at university. And we're also going towards looking at non-standard language, perhaps, formality, register, and I'll define what we mean by register later in the talk. Okay, let's start off with some thoughts on how do you relate language to context, to the world. Well, there's many different approaches to how this might be done, and we'll just look at a sort of simple case of reference where Lawrence Barsalou, for instance, has proposed that you could have a relatively sort of close mapping of what you see into the concepts that you derive. So you can see that, well, on the form side, you can write cup differently. They could also look differently when they look at what does the thing that cup refers to look like. And then you have correspondingly, very different representations in the mind. An alternative, but in style similar, approach would be by Ben Bergen and Nancy Chang in the tradition of construction grammar, where again you have a form side. Here are different spellings of cat, capitalized or not. And on the sort of meaning side, you see sort of reference. For each, you can have a schema. You would sort of, integrate those, link those to form the representation as a bipolar construction of form to meaning. And then from cognitive linguistics, Ray Dackendorf has proposed that you could link conceptual meaning representations to the sort of context, to the world, via a so-called referential tier. If you have a conceptual tier, we have an event, a fox eats grapes. You could index individual parts of that conceptual representation and match them with indices for things in the world. So these are all different variants that one could rely on thinking about how to accommodate language processing. So these are static representations for the time being here. Not all of them, actually. If you're thinking about Barsalou, he assumes simulations, and so do Bergen and Chang. So there's a mechanism in there as well, but we'll get to that in a little while. Okay, when we're sort of looking at language in context, how do we put things together? Glenberg and Cash proposed that there's a sort of type of interaction between syntax and semantics that leads to understanding. The syntax specifies a general scene, and the occurrences of objects are used to specify the scene in detail sufficient to take action. So this is sort of another tradition where language is envisaged as for action, but you also need to sort of put things together, and that's what the syntax does. It sort of makes the rules of combining elements to give you meaning that then can, subserve action. And here we're getting a little bit more into processing, away from sort of just thinking about representations. But if you're really wanting to move towards real time, most of the accounts don't really specify the time that well yet. So there is the indexical hypothesis by Glenberg and Robertson as another proposal, where there's no claims regarding the precise integration of experience with objects, the language that you're processing, and information in context. And what I mean by precise is exactly making predictions at what word in the sentence would context be integrated, and would it be integrated when you've just glanced at the word, or perhaps do you need to look at it 2 or 3 times before you can integrate context to a certain extent. So yeah, the precise integration is very much an open issue. Instead, the focus is often on the nature of the representations. Are they embodied? Do they share something with the original perception, or do we abstract away more, or perhaps even both? Barsalou has made a proposal here also for comprehension in a discourse journal, and also Rolf Zwan has a sort of this together with Larry Taylor, where you're seeing beginnings of thinking about timing in a more detailed manner. Well, now let's shift away from thoughts about theory towards empirical evidence. And while we zoom in on that in real time, we also zoom back in history to 1974, where Cooper pioneered a method that has only then been discovered by Mike Tannenhaus and has been much used in the field as the so-called visual world paradigm. So what Cooper did was he presented auditory speech input that you see here in writing. It's presented as speech together with a grid, like you can see depicted here. And as people heard the words in this longer discourse, they tended to look quickly at things that were related to the discourse, and not only reference, but beyond reference. So for photographic, for instance, it's not a referential term for camera, but triggered looks to the camera. You can see this indicated by the C here for camera, and the arrow indicates that looks started and how long they lasted. So for safari in Africa, looks went to the lion, and for breathtaking, that triggered associations, in this case, probably with a snake. Terrain, there's no terrain depicted, but that there's a tree that could be associated with terrain. Dog, now this would be a referential expression, and it did trigger looks to the dog, other things. Wormed, associations with a snake. Branches are part of a tree, so people tend to relatively quickly. So this is about temporal coordination of language, comprehension, and attention, shift their attention to relevant parts of the scene. or later on, it goes beyond reference quite clearly. The sort of discourse where somebody is taking photos, and then as I grab, camera hasn't been mentioned yet, but with grabbing, it was clear that the target could likely be the camera, and so looks at the verb shifted to the camera. This also works for pronouns, but before the line is even mentioned, looks go to the line, because the prior discourse made it clear that he was a likely referent in the later discourse. Okay, so very much pioneering work in the early 70s, and not just on the empirical side, also in terms of realizing the importance of what he had found there. Cooper concluded, in particular, the scanning of those elements which are most closely related to a given word should be initiated during or closely following the enunciation of that word and without prior instruction to do so. This is just happening. He then goes on to say, such behavior, if confirmed, could be viewed as an active, online, anticipative process. So the idea of expectations that can be expressed via attentionship already in there, whereby the contemporary visual field of an observer is subjected to his continual interpretation in terms of the language heard, and conversely as a process in which ongoing heard language is interpreted word by word in the context of the contemporary visual field. So quite visionary very early on. All right, since then there has been tremendous amount of studies documenting for many aspects of linguistic and world knowledge that context effects in language processing are incremental. Sometimes context can restrict that as much that you actually can sort of anticipate what comes next. This has been done for reference, for information about the size of objects, case marking, verb meaning and verb selection restrictions, and a combination of these for pronoun resolution, but also in the pragmatic domain for both children and adults. Well, with limited effects of context in children, actually, at that point, which is interesting. Effects of scene context have also been investigated, and we can use the method to look at sort of forward-looking processes, expecting what comes next, but also integrating we have just seen in context with current patterns. So how pervasive is this notion of incrementality and perhaps even anticipatory processing? Well, let's start first, before we get into that question, with thinking more about how can we accommodate these sorts of context effects that seem to happen relatively pervasively and relatively incrementally during comprehension. Well, so we need representation on the language side, as we've just seen early on in the talk. We also want to represent the context, be it now a pictorial context or a linguistic context. Both could provide important information, of course, linked via linguistic and world knowledge. So that's sort of supporting the representations. And crucially, an attention mechanism. That attention mechanism could be internal, shifting over representations of something that you've just seen, that you have extracted from the context, or looking at things that are right in front of you. All right. So what does this account look like in more detail? There's 3 steps assumed. The first sentence interpretation step. So this is sort of diving in with start to interpret language in relation to the scene. Sentence interpretation is the first step. Then once you've got an interpretation, you can mediate attention to things in working memory, representations, or to things right in front of you, and then you integrate the representations as each word comes in. You're updating the interpretation, and you're also updating expectations that you may have. You're keeping track of this in a working memory. Don't get too bogged down with the indices. They're just kind of locating the interpretation, the expectations, and the scene context to time steps. So I would be the current one, and this assumes we've got a representation of a preceding context. I double prime, that's from the last step, scene integration, -1, the word before. Okay. Right. So we interpret the incoming word in build an interpretation that could trigger a search for a referent. That's the assumption in the account, actually. And it could also trigger looks or shifts of attention internally based on expectations that you have formed. If you see new things, you might merge these with past context. But representations can, of course, also decay if they're no longer supported by things right in front of you. Again, you keep track of information in working memory. And then in a final step here for this given word that we're looking at right now, word I, you're reconciling the interpretation and the context representations here as seen. How do you reconcile them? Well, we're taking Jackendorf's sort of indexing idea and assuming that we can, for linguistic purposes here, do this via co-indexing. You could also revise the interpretation if that's called for by what you've seen in context, and reconcile the expectations, update them with what you know from the context. All right, again, you keep track of all of these in working memory. Right, and then the next word comes in and the cycle resumes. The steps in the cycle can occur in parallel, but there is some seriality, right? A referential search based on a word requires that you've heard the word and included it in the interpretation, understood it. Okay, let's look at an example. How could we accommodate this? We are going to look at one example from event-related brain potentials, where participants saw an image here of a gymnast punching a journalist. And then in rapid serial visual presentation, they saw words on the display that related more or less to the preceding clip art depiction. So here, the gymnast, for instance, and then applauds. Now, this doesn't match. So it's a mismatch manipulation like the one I sketched initially on the first slide. So probably processing difficulty would ensue here and be revealed in brain potential averages, amplitude averages that you can compare then to conditions where it matches, where you see a gymnast applauding a journalist. We can look at, is there a deviation, for instance? Is that deviation happening right there? What sort of effect are we getting? But there's different kinds of mismatches. You could also assume that you've seen a role reversal, right? You see a journalist punching a gymnast, but the sentence describes that the gymnast is doing something, not the case here. And also the action mismatches the verb. So that would sort of be an example of a double match. And of course, everything could match. So what do you find these kinds of experiments with student populations? You find distinct mismatch effects. So depending on whether the action or the role mismatches, you get different effects with a different time course and different sort of, brain correlates. There's also variability as a function of how quickly is the sentence presented, the words in the sentence, and do the participants have high or low working memory. So beginning to see variability emerge here that we would want to account for in the coordinated interplay account. And this is what we are going to look at next here. How could we bring in variability as a function of, say, participant characteristics? They differ in their working memory, or as a function of different relations between words in a sentence and contextual representations, so representations for both of these, actually, sentence and context. So nothing changes in the basic functioning of the account, but we're going to have to extend it to cover this. We need a timing parameter that I won't talk about much right now, but we do want a working memory parameter to also capture variability as a function of high or low working memory. You might gain more complete representations if you're sort of high working memory comprehender compared to low working memory comprehenders. Then we also want to track via indices, in this case, attached to the interpretation. What type of process is it? Are we relating a verb to an action, or is it more compositional? Are we relating thematic role relations of the sentence to role relations depicted in the world and here in the picture? We are going to need an index of the type of process and of the truth value, also for the contextual representations, and a response index, since in this particular study, I've glossed over that the task was to verify, does the sentence match the picture or not? All right. Otherwise, since interpretation guides as before, attention here internally, since you've seen the picture, you've gleaned representations from it, thus the assumption, and that can internally guide your attention to reference. You're keeping track in working memory of the representations. Then you come to the third step, scene integration, where you're reconciling the interpretation with the scene. And now there's a possibility that can also obviously fail, which it can, as we have seen, and we want to track that also in the account. All right, that was an abstract rendering of how the account could be extended. What would happen now if we plug in words as participants get the sentence? What would the account assume here? So we are doing this in bigger chunks of constituents. The gymnast is red, and this is for an example where participants, you can see this in scene, I double prime minus 1 here, they've seen a journalist punching a gymnast. So when they read the gymnast, and they may very well, based on frequency and what happens most often, assume that the gymnast is the agent here, they might integrate that constituent into the interpretation and give it an agent role early on. They might also have certain expectations as to how it goes on, and those could come from the preceding scene, possibly. Now, the sentence interpretation can guide attention, and now here the attention would shift across the representations, plausibly from the gymnast in the interpretation to looking for a referent or a role match in the scene. So journalist, gymnast landing on the gymnast, but then of course the role assignment doesn't match. You can also visit the expectations that you had, and then reconcile both of these, interpretation and scene representations, in the third step, where now with the revised keeping track of the role relations mismatch, both in the interpretation and in the scene representation, you're setting the response index to false. All right. Now, if you're getting to the next part of the sentence, applauded, for instance, you're again assuming working memory is high, so rapid integration of context could be assumed here. You're extending the interpretation with the verb, and in the next step, your attention might shift from the verb to the action in the scene representations. Again, this doesn't match. So based on the scene, you saw there's a sort of punching action here. The verb is applauds. A mismatch is predicted to ensue. So here we are making predictions for specific regions in the sentence, for specific words in the sentence. The assumption in this account is a close temporal coordination, so effects occur as soon as they could occur. All right, and then you reconcile these, and again, you're keeping track of the mismatches that occurred here. All right, so we've heard a little bit about language representations in context, and first extension of the coordinated interplay account to distinct contextual relations. Let's continue somewhat with this topic by looking at another language user characteristic, age. We're going to compare 4 to 5-year-old students and older adults, looking at context effects in different age groups, and also, again, context effects for distinct context language relations. One more directly referential, a verb, again relating to an action in an event depiction, but then also starting to look at indirect relations like a style in a preceding context belonging to a speaker. To what extent might that be linked to valence words in the sentence, such as a verb-adverb sequence, for instance? So would these kinds of context effects occur? They're quite different, right? So we might not necessarily predict similarities. But if you're thinking about the importance of social aspects in our life, we might see strong effects, and perhaps as strong as for referential relations. On the other hand, reference tends to be a very strong frequency-based and also developmentally grounded meaning relation in language. So what did this experiment look like? Participants in this experiment, the 3 age groups, each saw a video actually of a speaker smiling or looking sad. Here you see the smiling version. And then there was a visual world trial. So it's eye tracking now in this version, spoken language processing. Sentences were something like, den Marienkäferkitzel vergnügt der Kater. What does that mean? It means the ladybug tickles happily the cat. But you might, when you hear the ladybug tickles happily the cat as translation, assume that the ladybug is doing the action. No, in German we have den at a sentence initial noun. It tells you that this is the object of the sentence, pretty much. And so the patient of the action. Okay, very plausibly. All right, what can we look at here? Well, we can look at how much with these rather unusual sentences, they're also unusual in German, they're grammatical, but not very frequent and not very usual out of context. So can other things in context help with processing these sentences? For instance, the depiction of an action. When you're hearing the ladybug tickles, you might be a bit surprised by the sort of ladybug being the patient, but if you actually see the tickling action, maybe that helps you compared to when you're not seeing the action. And furthermore, in the sentence, there's a mention of a happy event, tickle. So perhaps you might already be primed by that if you've seen a happy speaker face, but not if you've seen a sad-looking speaker face or negatively valenced. And how do these two kinds of context effects shift across age groups? We're going to look in particular during the sentence at the verb and the adverb. Recall the account predicts immediate effects of these contextual relations in processing. Now, very quickly on to the results. What you can see here is 4 graphs, 2 on the left-hand side for the younger adults at the verb region, an action effect, and below the prime face side, upper panel C, children to 5-year-olds at the verb. What does the action effect look like? That's when it could occur, okay? And below that, old adults at the verb adverb, and I'm going to say something about the shifts and why it's sometimes verb and why it's sometimes verb adverb. Again, the action effect. What are we measuring here? Well, we are looking at how quickly do people understand the sentence, and we are measuring that by them shifting their attention early on during the verb to the next agent in the sentence, the tomcat here in this example, right? The ladybug is being tickled by the tomcat. So to what extent do they shift to that character versus the other character on the image, the rat? Okay. We're comparing actions are present or no actions are present, and the speaker's face matches happily in the sentence, or it mismatches that. Now you can see the action effects for the adults when the action is depicted. What this sort of large bar here indicates is that they're looking quite a lot at the tomcat. What we are using here is mean log ratio of looks, so it's a ratio of looks to the tomcat versus overlooks to the rat. That's much reduced when the actions were in present. So the case marking alone, when the action's not there, it doesn't tell you who of these two is doing anything, right? Plus, there's a bit of a mismatch then, arguably. So a quick effect benefit of the action in anticipating the correct target agent. That's also there for the kids, perhaps a little bit less of a difference. And it's there for the older adults, though a bit later, sort of more over an extended region. And while this effect occurs in all age groups, there are differences between the young and the older adults, qualified by an interaction of action depiction with age. So relatively robust sets of the actions with some difference in the time course. What was striking, though, is that an effect of the prime phase, wrong animation, an effect of the prime phase was really only clearly present in the younger adults. There was interaction that was just significant of age and the prime phase manipulation. So it was much stronger the effect for the younger adults than for the children. So we're seeing here clear variability as a function of age, and what in context is actually affecting language processing. How is it related, we think, to language? Is it directly referential or more tangentially, potentially related? Okay, so based on these and other findings, we thought that we should, also other findings in the literature, of course, that we should foreground social aspects more in modeling context effects. And Katja Marquardt, here still labeled as Münster, now Marquardt, has come up with this account in her research and has included comprehender characteristics more fully into the account. So for instance, age and its impact on cognition and behavior may percolate into context effects in language comprehension, but also comprehenders' experiences over time, literacy within mood, stereotypes about groups of people, or other beliefs and world knowledge, they have a rapid effect. So to capture this, Katja Marquardt introduced ProCom as a variable that contains the properties of the comprehender, and they can then modulate language processing and the interpretation here. She's also come up with a more explicit graded notion of the expectation, so to capture that these can differ, are not sort of a 0 or 1, but rather they're graded and can vary as a function of properties of the comprehender, among other things. Moving further on from this, we said we're going to look at variability at different context language relations, at different participant characteristics, age group in particular, but what about further non-standard languages that potentially a real gap in language processing accounts when we consider the case of register. And this is something we're doing in the Collaborative Research Council register here at the Humboldt University. What do we mean by that? Well, cases of non-standard language like register dialects and register we define as situation-specific and functional, so linguistic features that are free and pervasive in a register because they perform specific communicative functions and they're required by the situational context. The simple example is, if you're in a pub, you might use a different register than when you're in a courtroom. Mm-hmm. So more or less formal would be one instantiation here. So what's missing then? If you're going back to the account, we've extended this with comprehender characteristics, so we could capture differences in their knowledge, their age, but we probably want the representations that captures also relevant social aspects like formality of a situation, so that mechanisms and basic representations can remain what we had, representations on the language side, representations on the scene side, informed by linguistic and knowledge, and linked via an attention mechanism. But these sort of added representations we would need to integrate in the assumed world knowledge here and linking it to linguistic knowledge. How could we capture congruence in formality of context and register in the account? And then I'll talk briefly an example result from the research that we're doing in this area. So consider now a different context, a linguistic context. I'm just going to read out paraphrase. The investigators discussed the most recent success of the department. The superintendent proclaimed in the meeting. So this is one example for a formal context in the experiment, and these materials have been normed. And we're looking at, well, if you've just processed the formal context, how quickly would you, much like before, rely on, in this case, formality in the context when you get to a later so-called target sentence. For instance, the detective duped. Now, duped is more part of a formal register than informal. So here we would imagine a good match and perhaps little processing difficulty. You read and understand the sentence without too much trouble. Now, how would we capture this? We've got the 3 steps: sentence interpretation, the detective duped. We're starting with the verb, utterance mediated attention as before, and scene integration now, context integration in the wider sense. In working memory, you're building the interpretation. You already have the detective as the subject of the sentence here, and then duped comes in. You're again keeping, so here at the interpretation, the expectations are kept track of, and the context. And you've got PROCOM now in the extended account with knowledge regarding grammar and register and the response index that we've talked about before. Now, what's different here is that we have introduced indices R with a superscript P to track register formality, and P can range from very formal to very informal. You can see here it's set to 1 as an extreme example. So we had a formal context, and the verb is also considered to be formal. So you can predict this verb in the sentence. PROCOM, as I said, tracks the language user's knowledge. Now, what happens at the mediating attention step? Again, attention here will shift over the words of the sentence that you're reading, and also to contextual representations. So it would be on the Pierte, but also shift over the context. And where I said before, we need representation to capture formality. Like this context right now, it's marked for register, but it's otherwise a black box. It's not yet specified. So this is something that we're looking forward to doing more in future research in collaboration with colleagues. You might also shift to your long-term knowledge and query that. And then in the 3rd step, after this sort of attention step, integrate the register with context formality and potentially other aspects. Here, there's a match, co-indexing succeeds. Now, by contrast, if we, before the same sentence, have read an informal context sentence, again, note, the girls gushed over the hottest snoop in the series, the girl whispered to the others. So this has been normed as an informal context on a scale from 0 to 50, relatively informal on average, and the target sentence stays the same. What would happen in the account? You have sentence interpretation at the 1st step. You're at the verb again. You're mediating attention, integrating the scene, and you assume the same representation for detective. Dupierte again, based on your register knowledge, could have a sort of high formality setting here, but the context is now tracked as being low informality. For demonstration purposes, we've just set it to 0 here. You again have the attention step. So attention can shift across the verb, the context, and in your long-term knowledge. You then reconcile at the ensuing step. And here, as met would be predicted to ensue at the verb. Remember, the account predicts a relatively close temporally coordinated integration. All right. What do we find when we look at this using eye tracking in reading? This is a brief glimpse of the results. What you can see here is plotted total reading time at the verb, so duped in this sentence as a function of register congruence. You've got the matches on the left, the mismatches on the right, and then you've got panels for formality ratings that we also look at to see how consistent any congruence effect would be. What you notice here is that the mismatches, as predicted, take longer to read at the verb than the matches, and that is consistent across different formality ratings, with an effect where, if it was higher in formality, reading times were a bit longer, and that could be because, these are less frequent words, for instance. Potentially, it could also be related to other aspects of formality and context. But what is interesting here is effectively that this says verb total reading time, right? For those of you knowing eye tracking, that probably was a red flag when I said, effects should occur closely temporally coordinated, because in eye tracking, you could use earlier measures. You could use something called first pass, where you're just counting the duration of looks when you first look at the word before you go anywhere else in the sentence. You could look at regression paths, sort of looking at duped and the left context, or at the total time, all the time spent on this region. And the point here is that we did not find any formality register congruence effect in first pass in the earliest looks to the word, but only in total reading time, which might include rereading the right, reading the right of the sentence and continuing, and just taking more time, perhaps because of more variability in register knowledge across participants, perhaps for other reasons of having to keep in working memory a relatively long linguistic context. So there's a bunch of reasons that we are following up to accommodate these findings more also at a sort of conceptual level. That the point remains that this is a point in case where the account doesn't make the right prediction, so one would need to adjust it, bringing other variables to capture this sort of ability. All right, conclusions. Referential relations in language processing as a context effect is only the tip of the iceberg. Much variability remains to be examined for a more inclusive picture among the many participant characteristics, where we can ask which ones and to what extent do they matter. How can we come up with more principled predictions for each of these also in relation to one another? And how does that then mesh with referential, non-referential, different and distinct world-language relations, where overall we may see less clear or less incremental effects in quite a number of cases that remains to be tested. What is important, I think, is to really accompany the experimental work with actively accommodating context effects via sufficiently explicit processing accounts. So it doesn't always have to be implemented computationally, but it should be as explicit as you can make it. With that, I conclude and thank our funders and umbrella program here, and also to postdoctoral staff members in my group who've given me very helpful comments on the extension of the CIA to include register. Last but not least, the Deutsche Forschungsgemeinschaft for their continued support in funding this sort of research. Thanks very much.
Okay, thank you, Pia, for your insightful presentation. I think we are going to have plenty of time for question and answer part, because our next presenter unfortunately would not be able to attend the conference. So let me just, I would like to ask the first question about PIC. Do you think different types of context, for example, visual context, linguistic context, or interpersonal relationship between the speakers can have varying impact on different domains of language use? For example, in the domain of humor, the visual information may have more weighted impact on language comprehension than it may have in the domain of, say, scientific discourse. What do you think?
Yeah, I think that's very likely, right? And that may also difference as a function of age and maturity. I mean, in the pragmatic domain, you see clear differences in children versus adults, for instance, and I would assume that much of humor also relies on pragmatic and world knowledge, which may differ across cultures, of course, right, and also across the lifespan with different generations, or as a function of how good you are already in terms of making pragmatic computations that are then fully understanding the humor, and intuitively sometimes there's this sort of pause and then the audience starts to laugh. So I would expect for humorous instances of language that require pragmatic computation effects to occur with quite a bit of delay. Then if you're thinking about other kinds of humor that rely, for instance, on ambiguity, for ambiguity resolution, we also know that there's often a delay, right? Because different possibilities competing with one another potentially, or you're searching for the right meaning. So that is also a possible source for delays and context effects if you're sort of trying to resolve an ambiguity that underlies a pun.
Thank you. And are these findings used currently in human-machine interaction technologies? I know you have been in contact with the Center for Cognitive Interaction Technology in Bielefeld University. So I assume you would be aware of the current state of AI technologies. Do they use these findings or incorporate them in their just machines or whatever they are engineering?
So my time and interaction with cognitive technology dates a while back to when I was still in Bielefeld. I've not really kept in touch that much, so I don't think I can give you an estimate of what's currently done there in language technology. At the time, I remember that people like Catherine Pelachot in Paris, for instance, were looking at social aspects in robotics, and mostly sort of looking at that also, I believe, developmentally with regards to, how would you use facial mimics in interactive settings. But in terms of going to the level of humor, I have to pass, I'm afraid. I don't know. But it's an interesting question, especially because, there is quite a lot of work in the area of companionship going on, right? Especially also in Asia, from what I know, where sort of bringing humor into the equation would probably be quite beneficial. You might run into trouble there, right? If you sort of just think about it, when you think about uncanny valley effects in robotics, right? When the robot gets too close to the human, and humor is a funny thing there, right? I don't know, the kind of humor that might work with machines could potentially be different than what works with humans.
Yeah, I see. Okay, thank you very much. We have a couple of questions here asked. The first one is, could you please elaborate a bit on the paradigm you used in your experiments? Did you use divided visual half-field paradigm to explore parafoveal information?
No, we have not used this, but if you are interested in that, I think Kara Federmeyer's research, she's to present, would be a very good source of information. She's using that paradigm quite a lot. Mm-hmm.
Okay. The next question is, can context effects be also explored through pupillometry in babies, if possible at all?
I would think so, right? There's a substantial amount of research in the meantime. Well, substantial is maybe a little too much, but there are individual studies that have looked at pupil size and cognitive effort, for instance. How would context be processed? Does it require effort? There's individual studies have looked at that over the years. For instance, for case marking, that's unusual at the beginning of a sentence, right? That you then have a sort of dilation in pupil size, and when it's unusual versus more expected, you can also very nicely use it to get at cognitive load in sort of social domains of emotional valence integration or mismatch effects, I think, and that has been done. So that would potentially also, because it doesn't require much of sort of shifts in attention, be a very useful measure for very young infants as well. Mostly with very young infants, you're using sort of look and listen paradigm, right? That's often those labs would use Toby trackers and sort of a bit more coarse-grained than the sort of ESSA research methods that are used in psycholinguistics labs. But yeah, to the extent that you, and I think you can get this information out of there, I think that would be a very valuable measure.
Thank you. The next question is, what would be the challenges of studying language in context using naturalistic tasks?
You need different trackers then, I think, right? The one we are using in the lab is a desktop tracker. There's a remote version, but even then, with the remote ESSA research tracker that we are using, the assumption is that you have a computer display in front of you. Now, you could present more naturalistic stimuli on that, videos, and that has been done. For instance, the Almeida and colleagues have a nice Frontiers papers where they looked at eye-checking in full-blown videos in relation to language processing. Going even more naturalistic into the wild, we've done it in one study using, if I recall correctly, an L tracker at the time, where you had a participant sitting opposite an experimenter and carrying out the experiment, carried out tasks, actions, and we looked at how these actions can affect language processing. And for the particular example, at least, we found very similar effects in the real world scenario compared to when you present the same videos just on the display in the lab. So methodologically, you need different equipment. In terms of the analyses, different challenges ensue when you're really going fully into the wild with their glasses, and these are often used in media studies, right? When you're going into a supermarket and looking at shelves and stuff like that, you have other noise that could happen in the background, in the environment, that you may want to tackle in the analyses. Perhaps a bit more difficult to have tightly matched comparisons. Those would probably be some of the challenges, but doable for sure.
Thank you. Our next question, how do you think the co-registration of EEG with eye tracking can potentially contribute to our understanding of context effects in language processing?
Yeah, that's a very nice question. I think integrating the two, because they're very complementary measures, they can reveal complementary aspects of cognitive processes, is a very nice idea. People have tried it. There's research by Olaf Dimmingen out of Potsdam here. There's research by Ina Bornkessel and colleagues, among others, Matthias Josefsky, I believe, also, who have established this in a sort of first set of studies. Most of these cases, to my knowledge, have used sort of fixation related potentials, where you sort of have the eye resting, and then once eye rests, you look at the sort of brain potential correlates. Since again, you have ongoing noise. When you move your eyes, that's not something that you would like to have in event-related brain potential study. Typically, you have a fixation dot in the center of the screen, as you're probably all aware. You try to keep your eyes still. So linking it like that is a good idea, I think. Yeah, I think great potential. Difficult to implement. Otherwise, we'd see many more studies out there using the co-registration.
Okay, thank you. And I think our last question is, do you think that providing more context in a dependency can lead to facilitation in resolving long-distance dependencies in line with expectation-based accounts, or it can add to the memory load that slows down processing in line with memory-based accounts?
Yeah, I could imagine that that's a case where you run into trouble with cognitive load and effort. I think there is a point where there would be overload, either because things decay in working memory, parts of context, parts of language. It would very much depend on how you set it up, right? What sort of context? What's the relation to relevant language in your target sentence? But yeah, could very plausibly be a case where working memory does play a role. Would it mix benefits of context? I don't know. That to my mind, that depends very much on the exact setup. Is an empirical issue. In terms of what the account would predict, that's an interesting case. There you would need to model closely, and we've not done this. So the account that I presented today, you wouldn't model more closely decay of information in working memory, right? I've pretty much swept that under the rug in how I talked about context representations. And so I think my approach to that would be to do that, to create predictions based on the account. And you'd need to instantiate that with some sort of decay function to make it work. Yeah.
Okay. Thank you. I think we have no more questions.
Thank you very much for the question. Interesting.
Yeah. Thank you very much for all. See you.